Hello students, good evening everyone. I hope all are doing well and I hope I am perfectly audible and visible to everyone. So those who are watching this particular live, just give me a hi in the comments to mark your attendance. So finally we are moving to the third part of the chapter, metals and non-metals. The last class we have been discussed about the chemical properties of the metals and non-metals, right? Hi Durgesh sir, good evening. Okay, anyway, welcome to Infinity Learn by Sri Chaitanya. This is Miss Surya, your chemistry mentor from Infinity Learn. So here we are directly moved to the next part of our chapter, that is about the chemical properties. We are discussing about the properties of metals and non-metals with dilute acids and the case of salt solutions. I hope you guys have revised the topics we have covered in the last class. I hope you understand everything, all the part in the last class. So here we are going to discuss about the content. As we are starting about the reactivity series. We have already seen some part of reactivity series in the last class. So here we will be discussing about the reactivity series. Then the reaction of metals and non-metals with acids, with dilute acids. Then finally we are moving to the reaction of metal with salt solution, metal with salt solutions. Then there will be an introduction of ionic compounds, how ionic compounds are forming, what are their properties. That is our content we are going to discuss in the today's class. Ready? So let us start with the reactivity series. We have seen that the reactivity series are the metals can be arranged in the order of their chemical reactivity. That is known as the activity series or the reactivity series. Let us see the reactivity series here. Yes, this is our reactivity series, right? They are arranging in the decreasing order of their reactivity. Those who are having the topmost of the series is having high reactivity. For example, here we can say that these are highly reactive metals. Then these are the less reactive metals. So based on the idea of how the metals are arranged in the reactivity series, we can find out whether the reaction can happen in the case of oxygen, in case of water, or how we can displace the metals. That is the basic idea about the reactivity series. So yesterday I have already told you like that we need to memorize all the metals in the reactivity series by using any of the code. So here there is an introduction about the reactivity series is given here. We have already seen, that's why I am not explaining too much here. So in the case of metals which is positioned at the top of the series will react more vigorously with water, like acids, water and oxygen. For example, we have already seen, right, whenever we are discussing about the reaction of metals with acids, reaction of metals with oxygen and water, the topmost elements, topmost metals like sodium and potassium will vigorously react with hot water, right? Cold water and hot water. So that is about the reactivity series case. I hope you understand about the reactivity series. Now let us directly move to the reaction of metals and non-metals with dilute acids. So what will be happening whenever a metal is reacting with dilute acids? Okay, what will be the product? What are you expecting? Please come and hear. What will be expecting? What will be the product you are expecting? Metal plus acid, as you have already discussed in your first chapter, right? Chemical reactions and equations. Second chapter, acid, bases and salts. You have already studied the reaction of metals with acids. So what will be the product you are getting? It will be a salt plus hydrogen, right? Whenever a metal is reacting with a dilute acid, we will get a salt. For example, if you are taking the hydrochloric acid as a acid here, we will get a chloride salt, right? Along with hydrogen. So this is the general reaction of metal with the dilute acid. Clear? Now let us see some examples here. First case, I am taking magnesium metal. I am taking magnesium metal. I am Durgeshwar, what is your doubt? What do you mean by dilute acids, right? Actually, I didn't get your question. I think you are asking about the dilute acids. Depending upon the concentration, there will be concentrated acids and dilute acids, right? So, in the case of dilute acids, which means that the concentrated acid is added to water, right? Water plus concentrated acid mixture is known as the dilute acid. I hope you understand. Which has less concentration as compared to the concentrated acid, that is known as the dilute acids. In case of dilute acid, more concentration of water, yes. We are mixing the concentrated acid with water, we will get the dilute acid. That is mean by the dilute acid. So here I am taking magnesium metal with hydrochloric acid. So generally what will get the product? It will be a salt, right? It will be a salt. Here if I am taking HCl, I will get a chloride, that is our salt, magnesium chloride plus hydrogen plus heat, because it is an exothermic reaction. During this reaction, you can say that heat is releasing. So this is an exothermic reaction. Clear? Next example, I am taking aluminium metal. I am taking aluminium metal reacting with the HCl, again hydrochloric acid. I will get the salt of aluminium as AlCl3, aluminium chloride plus hydrogen plus heat, again exothermic reaction. So all the reaction of metals with dilute acids is an exothermic reaction because the heat is released there. Clear? Then balancing of the reaction is very important, as you have already studied in your first chapter, chemical reactions and equations. So you need to balance all the reactions here. Then next one, zinc. Zinc plus HCl, I will get the product as ZnCl2. ZnCl2 means zinc chloride plus hydrogen plus heat. I hope you understand. Now you may get the confusion that why we are only using HCl. Is it possible to react with the H2SO4? Is it possible? For example, if I am taking magnesium, right, I am taking magnesium, instead of hydrochloric acid, I am taking H2SO4, dilute sulfuric acid. What will be the product I am getting? Can anyone please say in the comment box? What will be the product? Just let me know the answer in comments. Mg plus H2SO4, as we already seen like that, whenever we are treating with the metals with sulfuric acid or any of the acid, right, we will get the corresponding salt. If we are taking HCl, hydrochloric acid, we will get the chloride. Similarly, if you are taking H2SO4, we will get the sulfate salt, right? Sulfate salt. Okay, no issues. You will get the answer as MgSO4 twice, right? Sorry, MgSO4. Clear? So, if you are taking H2SO4 as the dilute acid there, we will get the sulfate salt as the product. If you are taking HCl as the acid there, we will get the chloride salt as the product there. I hope you understand. Clear? Okay, here one more point we have to keep in mind, that this is the displacement reaction. I hope you must have studied in the case of chemical reactions and equations about the displacement reaction, right? First chapter. So displacement reaction here means the magnesium metal is displacing hydrogen from the HCl, which means that magnesium is more reactive than the hydrogen. If you are talking about the reactivity series, there will be some of the metals, right? The topmost metals are having the high reactivity as compared to hydrogen. So we can say that whenever the metals are reacting with the acids, we can say that these metals can displace the hydrogen atom if they are reactive than the hydrogen. I hope you got my point. Clear? Is that fine? Let us see the reactivity series here. Yes. So this is our position of hydrogen, right? This is our position of hydrogen. Those who are above the hydrogen atom can displace the hydrogen from the particular acid. For example, if you are taking potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, it can displace the hydrogen atom from the corresponding acids to get the corresponding salt, right? But for example, if you are taking copper, mercury, silver or gold, if you are reacting those with the particular acid, you will not get the corresponding salt. Clear? Is that clear? I hope you understand my point. Fine. Now, we have seen about the two types of acids here, right? If you are taking HCl, we will get the corresponding chloride salt. If you are taking H2SO4, we will get the corresponding sulfurous salt. Now, there is a special case for the HNO3, nitric acid, right? Nitric acid. This is a special case. We are expecting that any of the metal which is reactive with the acid, they will produce the salt plus hydrogen, right? Salt plus hydrogen. So, we may predict that metal react with dilute HNO3 to form metal nitrate, right? Metal nitrate, their salt plus hydrogen. But here what is happening? Instead of hydrogen, we are getting water as the product. Clear? This is a special case in the case of nitric acid only. If you are taking the acid as a dilute nitric acid, instead of hydrogen gas, we will get water. What is the reason behind that? Durgeshwar, what? This point, right? This one, right? This means there is no reaction. No reaction. This X means no reaction. Clear? So why it is happening like that if you are using HNO3? As we already know, you have idea about the oxidizing agent and reducing agent, right? So in the case of HNO3 or the nitric acid, it is a strong oxidizing agent. It is a strong oxidizing agent. So in the first case, whenever the metal is reacting with the HNO3, it will first produce the hydrogen gas. Then because of the strong oxidizing power of the HNO3, this hydrogen can be oxidized to water. For example, if I am writing here, because of the strong oxidizing power of HNO3, the hydrogen atom get oxidized to corresponding water. That's why we are getting the water as a final product instead of hydrogen whenever it is reacting with the HNO3. Clear? So, HNO3 is a strong oxidizing agent. It oxidizes the hydrogen to water and itself get reduced to NO, NO2 or N2O. So, whenever the metal is reacting with the dilute HNO3, we will get a salt, corresponding metal nitrate salt, plus water, plus any of the nitric oxide, any of the nitrogen oxide. I hope you understand. Clear? Then just like all other elements like silver, gold, copper, and which is below the hydrogen atom in the reactivity series does not give any reaction with the corresponding acids. If you are taking HCl, H2SO4, HNO3, it will not give the product as corresponding salt. Then again one more exception is here. As we already said that whenever we are using HNO3, we will not get the water as, we will not get the hydrogen as the product, right? But there is an exceptional case. If you are taking magnesium, if you are using very dilute HNO3, I will get the product as MgNO3 twice, right? MgNO3 twice, that is the magnesium nitrate plus hydrogen. So this is an exceptional case. Clear? The reason is that if you are using very dilute HNO3, the oxidizing power of very dilute HNO3 is as less as compared to the dilute HNO3. So that is why they are forming hydrogen itself. Clear? Okay, fine. Now, what will happen to the case of non-metals? Non-metals. As we already seen like that, the reaction of non-metals with oxygen and water, right? If the non-metals are reacting with oxygen, they will produce the acidic oxides. If they are reacting with the water, there will not be any reaction happens, right? In the case of non-metals, discussed in the last class. Similarly, if you are reacting the non-metals with acid also, there will not be any reaction. Clear? What will be the reason behind that? Why they are not reacting with the, sorry, this is dilute acid. Okay, what will be the reason behind that? We have already seen the reaction between metals and dilute acid, right? Metals and dilute acid. Here the metal is the electropositive in nature, which can donate the electrons so that it can displace the hydrogen atoms. But in the case of non-metals, they are electronegative in nature, right? They are electronegative in nature. They cannot donate electrons, they can accept electrons. That is the reason why they are not reacting with the dilute acid at all. Is that clear? So far we have discussed about the reaction of metals and non-metals with the acids. Now we are going to discuss about the reaction of metals with the salt solution. Here we are focusing on the displacement reaction. First case I am taking a metal, I am taking here as zinc, then I am treating with the salt solution of another metal. Here I am taking zinc as a pure metal here, then I am treating with the sulfate solution of copper sulfate. Both zinc and copper are metals, right? What you are observing here, zinc is the metal, right? The zinc is displaced in the copper from the copper sulfate solution and it is producing certain SO4 plus copper. So what you are observing here, this is a displacement reaction, right? Displacement reaction. So the zinc is displacing copper from the copper sulfate solution to producing zinc sulfate plus pure copper. So this is the displacement reaction. So how we can predict the reactivity of zinc and copper according to this reaction? Which one is more reactive, whether zinc or copper? That is the importance of reactivity series. Just let me know the answer. If you are comparing this reaction here, zinc displacing copper from the copper sulfate solution, then how we can predict the reactivity series of zinc and copper? Which one is more reactive? Yes, zinc is more reactive, right? Yes, very good, Indira. Zinc is more reactive than the copper. That is why they are displacing the copper from the copper sulfate solution. So, by reactivity series, we can say that zinc is more reactive than copper. Same you can check with the reactivity series also. Clear? Now, if you are doing the experiment part, I am taking a copper sulfate solution in the beaker. Now, I am dipping a strip of zinc over it. You can observe a color change that. What is the color of copper sulfate solution? What is the color of pure copper sulfate solution? Blue color, right? Yes, copper sulfate solution is having the blue color. Whenever I am placing a strip of zinc over it, after a few times, after some time, what is happening here? Zinc sulfate solution is forming colorless. Solution become colorless, but in the zinc strip there is a red brown deposit of copper is observed, right? We will observe a reddish brown deposit of copper over the zinc strip. Clear? So this is the experimental part for the displacement reaction. Now let us see another example here. Okay. Instead of zinc, I am taking iron in copper sulfate solution. What will be the product getting here? Ferrous sulfate, right? Iron is displacing copper from the copper sulfate to producing ferrous sulfate plus copper. So which one is more reactive? Which one is more reactive? Iron is more reactive, right? Iron is more reactive than copper. That is why they are displacing copper from the copper sulfate solution. So this is the importance of reactivity series in the case of displacement reaction. If you are familiar with the metals in the reactivity series, we can predict the reaction happens or not. Is that clear? Yes. Yes, iron is more reactive, right? Okay, fine. Now, there is another question for you. If I am taking copper plus zinc sulfate solution, what will be the product you are expecting? What will be the product you are expecting? The answer is itself there in the slide. Whether this reaction happens or not, that is the question. If I am placing a strip of copper over the zinc sulfate solution, what I am observing, if I get any solution, if I get any reaction, if it will happen any deposit on the copper on the zinc, deposit of zinc on the copper strip or not. Indira, are you sure? Copper sulfate is the product? Just think about the reactivity series, how the reactivity of copper and zinc varies. Which one is more reactive? No reaction, right? Yes, correct. There will not be no reaction. So if you are writing down the reactivity series, you can say that zinc is more reactive than the copper, right? Zinc is more reactive than the copper. So zinc can displace the copper, but copper cannot be displace the zinc, right? So if you are taking here copper plus zinc sulfate, copper cannot be displace the zinc from the zinc sulfate solution because of the reactivity difference. So we will not get any reaction here. Is that clear? Is that clear? So in order to answer these type of question, you need to memorize the complete metals in the reactivity series. Clear? Yes. Now let us practice some questions here. Here is the first question. Yes. Which metal is more reactive in the reactivity series? Which metal is more reactive in the reactivity series? Options are given here: aluminium, zinc, sodium and potassium. What will be the answer? If you are familiar with the reactivity series, the topmost element, topmost metal in the reactivity series is the correct answer here. Yes, Durgesh, option D, right? Potassium. Any other options or any other answers? Yes, potassium is the correct answer. So if you are familiar about the reactivity series, you can say that they are starting from the potassium, sodium, calcium, right? So potassium is the most reactive metal in the reactivity series. So here option D will be our correct answer. Now let me move to the next question. Yes. The pair or pairs will show displacement reaction is or are. For different options are given here, you need to identify whether these solutions will show displacement reaction. Read the question carefully, then let me know the answer. You can get multiple answers here. Durgeshwar, I didn't get your question. How many reactive series? There is only one reactivity series, right? For metals, there is only reactivity series there. There is only one reactivity series. You can refer from your NCERT textbook itself. Option D, right? Read the options carefully. You may get more than one answers here. That's why the question is asking about whether pair or pairs. First option is given as NaCl solution in copper metal. Second one, AgNO3 solution in copper metal. Third one, aluminium sulfate solution in magnesium metal. And the last one, SO4 solution in iron metal. Okay, what will be the answer? Okay, in the reactivity series, I think it is around 14 or 15. I don't exactly remember the number. It's around 14, 15. Metals are there. Okay, Durgeshwar, what is your final answer? Okay, let us see what are the answer. B and C is the correct answer. So if you are talking about the first case, NaCl solution copper metal, right? NaCl and copper metal. If you are comparing the reactivity series, copper is less reactive than the sodium, right? Copper is less reactive than the sodium. So we can say that there will not be displacement reaction happen. So this is the one case which is not happening, the displacement reaction. Now AgNO3 solution in copper metal. If you are comparing the reactivity of copper and silver, silver is down the series, right? Silver is down the series, copper is here. Yes, copper is here, right? Copper is more reactive than the silver. So we can say that displacement reaction happens here because copper can displace silver from the silver nitrate solution. So that is the one case. Then if you are talking about the second case, aluminum sulfate solution and magnesium metal. Aluminum sulfate solution and magnesium metal. If you are comparing the reactivity of magnesium and aluminum, we can say that magnesium is more reactive than the aluminum as according to the reactivity series, right? So magnesium can displace the aluminum from the corresponding salt solution. Clear? Then last one, SO4 solution in iron metal. If you are comparing the reactivity of zinc and iron is less reactive than the zinc. So there will not be a displacement reaction happens. So there are two options, that is B and C are the correct options which is showing displacement reaction. Is that clear? Durgeshwar? Is that clear? Don't get confused with the fourth option here, ZnSO4 solution in iron metal. As compared to the reactivity series, we can say that zinc is more reactive than the iron, or iron is less reactive than zinc, so it cannot displace the zinc from the zinc sulfate solution. I hope you understand. Yes. Here is another question. This is an assertion reason type question. The assertion is hydrogen gas is not evolved when zinc reacts with nitric acid. And the reason is nitric acid oxidizes hydrogen gas to water and itself get reduced. You need to check whether these assertion and reason are correct and if it is the exact explanation for the assertion. Read the question carefully. Yes, option A is the correct answer, right? Yes, option A is the correct answer here. We have already seen, right? In the case of nitric acid, if you are taking any of the metals except magnesium, and one more case is the magnesium and manganese. So if you are taking magnesium or manganese, whenever you are reacting with the dilute HNO3, you will get the hydrogen as the product. But if you are taking any other metals like zinc, it does not produce hydrogen, right? Because of the higher oxidizing power or oxidizing character of the HNO3. So assertion is correct here, reason is also correct here, and reason is the exact explanation for the assertion, right? So option A will be our correct answer. Clear? Okay, fine. Now let us move to the next topic here. What will happen whenever the metals and non-metals react? What will happen whenever the metals and non-metals react? Do you have any idea? Metals are electropositive in nature, right? Metals are electropositive in nature, which means that it can donate the electrons, right? It can donate the electrons. Non-metals are electronegative in nature. It can accept the electrons, right? So whenever a metal and non-metal are reacting together, one loses the electron and the other one gains the electron. So it is forming anions. It is forming ions, cations and anions. Clear? So when metals and non-metals react with each other, they form compounds known as ionic compounds. Ionic compounds, right? So in these compounds, the ions are held together by a special bond. That particular bond is known as the ionic bond or electrovalent bond. You must be studying in detail in the chemical bonding chapter. I think the 4th chapter or something. About the ionic bond, covalent bond. So here you need to keep in mind that whenever the metals and non-metals reacting together, metals have a tendency to lose electrons, right? And the non-metals have a tendency to accept electrons. Whenever they are reacting together, they will form a compound known as ionic compounds because of the formation of an ionic bond between them. I hope you understand. Same point is repeating here. So, by losing electrons, metals have the tendency to lose electrons, right? By losing electrons, they will form a positively charged ions known as cations. For example, in the case of sodium, sodium is a metal, right? It is having the electronic configuration of 281. It has a one lost bound electron here, right? So, it has a tendency to lose electron to form Na plus ion, right? Finally, it will form the electronic configuration of 28 in order to attain the stability. Clear? So, the metals, whenever reacting with the non-metals, they will lose one electron from the outermost orbital to form corresponding cations. Clear? Yes, same is happening here. This is the pictorial representation given here. Sodium is having the electronic configuration of 281, right? This is the one electron which is going to be donated by the sodium atom, right? Sodium atom. So, this electron is removed from here. The removal of this electron will form the Na plus ion or the sodium cation. Clear? Now, what will happen to the non-metals? What will happen to the non-metals? Similarly, non-metals have the tendency to accept electrons, right? Tendency to accept electrons. So, whenever they are reacting with the metals, the electrons lost from the metals can be accepted by the non-metals, right? So, non-metal atoms have a tendency to accept electrons in order to complete their outer shells. So, they are becoming negatively charged ions known as anions. Because of the formation of these ions, these particular compounds are known as ionic compounds. I hope you understand. Clear? Here I am taking Cl, chlorine atom, right? So, it will be 287, right? 287. In order to attain stability, it needs one electron to the outer orbital, right? So, those electrons lost from the sodium get accepted by the chlorine atom to form Cl minus ion. Clear? That's why it is forming 288. This is a Cl minus ion, chlorine anion. Clear? So, we have seen one ionic compound here, right? Sodium and chlorine react to form. Sodium and chlorine react to form sodium chloride, right? So, this is an example of ionic compound here, sodium chloride. Next, another case it is same, it is repeating. Metals and non-metals lead to the formation of compounds that possess charged species. These charged species are known as ions. The metals are forming cations and the non-metals are forming anions. The oppositely charged positive and negative ions held together by a bond known as ionic bond. That is why these compounds are known as ionic compounds. Clear? Again, this is the pictorial representation. One of the electron from the sodium is releasing, so it will form the Na plus ion. It is accepted by the fluorine atom here. It is accepted by the fluorine atom here. I hope Indira, now you understand, right? Clear? So, one of the electron lost from the sodium will act with the fluorine to form sodium fluoride as a compound here. Another example of the ionic compound. Now, what are the examples of ionic compounds? You can see some examples of ionic compounds in the real life. First one, it is sodium chloride, our table salt, right? Hi Pratibha. Our sodium chloride, that is stable salt. Then sodium bicarbonate, as you already know about as the baking soda, which is used in the bakeries, right? Not to cook food. Sodium bicarbonate, that is NaHCO3. Then sodium hydroxide, it is used as a dry cleaner, NaOH. Then magnesium sulfate, which is known as the Epsom salt. Then sodium hypochlorite, which is used as a bleach, NaOCl. These are the examples of ionic compounds which is used in the real life examples. Clear? Now we need to see how these formation of particular ionic compounds is forming in the terms of Lewis dot structures. So, what is the atomic number of magnesium? Here we are discussing about the formation of magnesium chloride. So, obviously, the cation is formed by the metal, right? So, metal is here, magnesium. So, it will form the corresponding cation. Then the non-metal is chlorine here, right? So, it will form the anion there. That is why they are forming an ionic compound of magnesium chloride. So, we have an idea that the metal will lose electrons, right? So, metal will lose electrons. So, in the case of magnesium, the atomic number is 12. Atomic number is 12, right? So, electronic configuration of magnesium is 282. 282. In order to attain the stability, what you have to do here, the magnesium want to lose these 2 electrons, right? They want to lose these 2 electrons, then only they will attain the stability. That is the octet rule. So, the number of electrons in the outermost orbit is 2. So, it will have the tendency to lose those 2 electrons. Clear? That is written here. Similarly, if you are taking the chlorine non-metal, atomic number is 17. Electronic configuration is 287. In order to attain stability or to get the octet here, it need to accept 1 electron, right? It need to accept 1 electron. So, the valence electron in the case of chlorine is 7. So, it need to accept 1 electron here. Clear? You must have idea about the electronic configuration. Just explain the electronic configuration here. Now, so here, in the case of 1 magnesium atom, there is 2 electrons are present there, right? In the case of valence orbital, there are 2 electrons are present. But in the case of chlorine, they need only 1 electron. In case of 1 chlorine, they need only 1 electron. So, in the case of magnesium chloride, the magnesium wants to release those 2 electrons. So, we need 2 chlorine atoms here. Clear? Is that clear? So, magnesium will lose 2 electrons from the outer orbital to form Mg2 plus cation. Then it will react with the 2 chlorine atoms. One of the chlorine will accept 1 electron from the magnesium. Similarly, another chlorine atom will accept 1 electron from the magnesium to form MgCl2 compound. That is our ionic compound formed here due to the reaction of magnesium and chloride. Mg is forming Mg2 plus and Cl is formed as 2Cl minus ion. Is that clear? Similarly, you can take it as a homework if you are treating with calcium and fluorine. How the dots symbols are forming. First, you need to identify which one is the metal here, which one is the non-metal here, what is their electronic configuration, what is the valence electrons there, how they are reacting. The calcium is losing how many electrons, fluorine is accepting how many electrons, how the structure is forming here. Just note it down, take it as a homework, try it in your home. Fine? Now let me move to the last part of the today's session, that is about the properties of ionic compounds. Properties of ionic compounds. First property, in the case of physical state, all the ionic compounds are solids in nature. All the ionic compounds are solids in nature. For example, if you are taking sodium chloride, right? Sodium chloride is a stable salt which is in the solid state. This is the most common example. Due to the strong attractive force between the metals and non-metals, right? Yes. Then, what is their nature? They are brittle. If you are applying any of the pressure over it, it will easily breaks down. That is the brittleness of the compound. So, in the case of ionic compounds, they are brittle in nature. Then, if you are asking about the melting and boiling point. What will be the melting and boiling point for the ionic compounds? Whether it is high or low. High, right? They have high melting point and boiling point because of the strong ionic bond formed in between the metals and non-metals. If you are asking about the strength of ionic bond, we can say that. If you are discussing about the chemical bonding chapter, we will get a more idea about that. If you are comparing with the ionic bond and covalent bond, ionic bond is more stronger than the covalent bond. So because of the presence of ionic bond in between the ionic compounds, they have high melting point and boiling point. We need more temperature, we need more energy to break those bonds. Clear? Now the another property is the solubility in water. If you are adding sodium chloride, if you are taking the sodium chloride as table salt in water, what will happen? Whether it is soluble or not? Salt water if you are making. It will soluble, right? If you are adding salt to the water, it will definitely solute. It will definitely soluble in water, right? Soluble in water. So, this is the general characteristic for the ionic compounds. For example, if you are taking sodium chloride, all the ionic compounds are soluble in water. But if you are taking any of the organic solvents, if you are taking any of the organic solvents like kerosene, petrol, etc., it will not soluble in these particular solvents. I hope you understand solubility. The next property is the conduction of electricity, whether these ionic compounds are conducting electricity. As you already know, you have an idea about it in the physics part. Electricity means movement of electrons, right? Movement of electrons. So, we need free electrons to conduct electricity. So, if you are taking ionic compounds in the solid state, similarly, if you are taking sodium chloride or something, we can say that there is a closely packed arrangement of the atoms, right? Sodium and chlorine is closely packed in the case of sodium chloride. So, in the case of solid state, there will not be any free movement of ions, right? There will not be any free ions. So, it will not conduct electricity. Note the point, ionic compounds in the solid state do not conduct electricity. But it will conduct electricity when it is in the molten state. Clear? Molten state means if you are applying heat over the ionic compounds, it will melt, right? So, the metal melt is known as the molten state. So, if you are applying heat over it, what will happen? The ions will start moving, right? That is why they are conducting electricity. So, this is the important point you have to keep in mind, that ionic compounds in the solid state does not conduct electricity, but the ionic compounds in the molten state can conduct electricity. Clear? Now, there is a pictorial representation if you are taking 3 different samples. First one, it is distilled water, and the second one, it is solid NaCl, solid compound, and the second one, it is the solution. What are you observing here? If I am taking a cell here, a bulb is making here, what you are observing here? I hope you understand the difference here. These two bulbs are not producing light, but this bulb is producing the light, which means it can conduct the electricity, it does not conduct the electricity. What is the reason behind that? Anyone? First case, it is the distilled water. What is the case of distilled water? Whether there will be any ions are present in the case of distilled water. Is it possible to conduct electricity? No, right? Please respond. In the case of distilled water, there is no any free ions present, right? So, they cannot conduct electricity. That is why this bulb is not lighting. Clear? Then, what about the case of solid substance? If you are taking a solid substance here, again, This is a closely packed arrangement of particular ions here, right? Closely packed arrangement. There is no any chance of free movement. There is no any chance of movement of the ions here, right? Again, there is no any chance for the conductivity side, right? It cannot conduct electricity. So that is why the bulb is not lighting here also. Then third case, solution. It is a solution, right? It is a solution. What you are observing here, both positive and negative ions are forming here. It has a tendency to move. There will be free ions present, right? It has a tendency to move towards the opposite electrodes, which means that if you are putting the positive and negative terminal here, right, the positive ion will move to the negative electrode and negative ion will move to the positive electrode due to the conduction of electricity. So in the solution state, they have the tendency to move electrons, so they will conduct electricity. That is why the bulb is lighting here. I hope you understand. Clear? Indra, is that clear or do I want to repeat again? Okay, again we need to practice some questions. Here is the first question. Aluminum chloride stands for Al2Cl3. You need to check whether the statement is true or false. True or false. Okay, this is again you have studied in the first chapter, chemical reactions and equations. You have studied about how to write down the chemical formula of the compound, right? If you have idea about the valencies of the particular compounds. Yes, false, right? So the correct answer is false here, which means that then what will be the correct answer here? What will be the correct answer here? Yes, Indra, you are correct. AlCl3 is the chemical formula for the aluminum chloride. How we can find that? How we can find that? This is an example of ionic compound, right? In the case of, for example, if I am taking aluminum chloride means, as we already know, aluminum is the metal, right? Aluminum is the metal. We have already known that aluminum is having the atomic number of 13, right? Atomic number of 13, so electronic configuration is 283. So what is the valency of this aluminum? Valency of this aluminum, it can lose 3 electrons to form the stability, right? To get the stability, so it will release 3 ions to form the Al3 plus, right? That is the valency of aluminum. Then what about the chlorine? What about the chlorine? Chlorine is a non-metal, right? 287 is the electronic configuration of chlorine here. Yes, 287 is the electronic configuration of chlorine. So it can accept 1 electron. It can accept 1 electron from the aluminum, right? So here 3 electrons can remove from the aluminum. So we need 3 chlorine atoms here, right? We need 3 chlorine atoms here. Cl minus 3 chlorine atoms. The one method you have to do like that, you need to crisscross. This is the valency of aluminum. This is the valency of 1. So you need to crisscross the valencies here. Then you will get the correct formula, AlCl3. Is that clear? Is that clear? So this part is very important to write down the chemical formula of the compounds. It is important in the case of this chapter also and in the case of first chapter also, chemical reactions and equations. You must have idea about the valencies, how we can write down the chemical formula of the compounds. Here specifically it is asking about the ionic compounds. I hope you understand. Here is the next question. The solution of one of the following compounds will conduct electricity. The compound is, 4 different options are given here. You need to identify the compound which conduct electricity in the solution state. Please give me the answer first. Options are given here. First one, it is carbon tetrachloride CCl4, then CH for methane, CaCl2 calcium chloride, and CH3Cl methyl chloride. What will be the answer? Indira is saying option C is the correct answer. Is there any other answers? Indira, what is the reason behind that? Why are you saying like that CaCl2 solution is conducting electricity? Here the question is asking about indirectly it is asking about which one is the ionic compound among these following. We need to identify the ionic compound because conduction of electricity is the property of ionic compound, right? So among the following, which one is the ionic compound? That is the exact question. But they are just twisting the question like this, which of the following solution will conduct electricity. So we can say that CaCl2, right? CaCl2. So option C is the correct answer here. CaCl2 is the ionic compound here. Ca is releasing 2 electrons to form Ca2 plus ion, and it will accelerate by the 2 chlorine ions to form 2 Cl minus ion. So this is the one of the ionic compound present here. That is why they are conducting electricity. Clear? Yes, fine. Now let us move to the last question. Which of the following property is not of ionic compound? We have seen about the different properties of the ionic compound, right? Based on the idea, you need to give answer for this question. Which of the following property is not of ionic compound? Options are given here: solubility in water, high melting and boiling point, electrical conductivity in solid state, and electrical conductivity in molten state. What will be the answer? Which one is the correct answer? Option A or 1, 2, 3 and 4. Yes, option 3, right? Option 3 is the correct answer. Electrical conductivity is in solid state. That is against the property of ionic compound, right? That is very important. If you are talking about the ionic compound, it cannot conduct electricity in the solid state because of the absence of free electrons, right? So it will conduct electricity in the molten state. So that is very important. I hope you understand, right? Okay, that's all about from my side for today. This is the thing we have studied in this class. I will just recap all the things we have studied in this class. We have studied about the chemical properties, right? We have studied about the chemical properties. We are starting with the reactivity series. You need to keep in mind about all the metals which is present in the reactivity series with using any of the code. Then, how we can displace the metals from the metal solution. That is one case we have studied. Then the reaction of metals and non-metals with acids, right? If you are taking dilute acid, what will happen to the reaction? What will happen to the reaction, whether it is exothermic, whether it is forming hydrogen or not. And the special case of nitric acid is very important. Right, then what else? We have seen about the formation of ionic compounds, right? Because of the formation of positive and negative ions, they are forming an ionic compound. We have seen the properties of ionic compounds also. So far we have discussed about the complete part about the metals and non-metals. We have seen from the starting, we have seen about the physical properties, chemical properties. The next class I will be coming back with the metallurgy part. This is another part of this metal and non-metal chapter, that is about the how we can extract the metals. There will be different methods to extract the metals. So metallurgy is the next part. So we have the regular timings of Tuesday, Thursday and Friday. Regular timing is 5 to 6 p.m. Tuesday, Thursday and Friday. So make sure that you will be attending all the classes with me. Keep a note over it about the timings and everything. So I hope you understand everything. And bye bye all of you. Thank you so much. If you really like the session, hit the like button, share this particular session to your friends, subscribe the YouTube channel, Infinity Learn 9 and 10 channel. And if you want a session PDF here, you want to join our Telegram channel, again Infinity Learn 9 and 10 Telegram channel, you will get the session PDF after all the classes here. Fine? So I think we can wind up the session for today. I hope you understand everything. So see you in the next class, in the next Tuesday, coming back with the metallurgy part. Till then, bye bye all of you. Thank you so much.